My name is Jim White. I'm a professor of Geological Sciences and Environmental Studies, and I'm the director of the Institute of Arctic and Alpine Research. My research areas, I have two main research areas. One is study of climate and how climate works. Mostly I use ice cores from Greenland and Antarctica to provide me the raw material that we make measurements on to look at climate change. Even more specifically, I'm very interested in climate changes that occur on timescales that human beings could get excited about. So 5, 10, 15, 20 years. The 1,000-year kind of timescale is interesting climatologically, but it's not of policy relevance. I also work on the carbon cycle. I'm one of those annoying people who tells you that when you drive your car, you produce carbon dioxide, and carbon dioxide accumulates in the atmosphere and changes the climate of our planet, plain and simple. One of the most important pieces of information that I don't see getting out in the public arena is just how important this last 30 years has been in terms of human impacts, not only on the climate system, but on the environment, on the planet Earth in general. In the last 30 years, we've reached that point of dominance on the planet that we have been trying to achieve for so long. We've actually achieved it. We are changing the climate. We have reached a point where we produce as much fertilizer for the plants that we grow, our crops, as all of the bacteria on the planet produce for the natural vegetation. We've changed fundamentally all the major functionings of the planet. And it's simply because there's 6.5 billion of us and growing, and the amount of resources we use per person is growing as well. Both of those things are growing exponentially. So I think this is one of those pieces of information, if people really sat down and thought about it, that indeed the planet has limits, and that this is probably the biggest watershed, the biggest moment historically in human history, I think, that we've reached a point of dominance on the planet, and we've gone from a point of, let's occupy the planet, let's use its resources, to how do we live sustainably on the planet? This is a huge challenge, and just a fundamental mental and paradigm shift. All of our economic systems are based on growth, growth, growth. We can't do that all the time. You have to reach a point where you've got to learn to live within the limits of the planet. And we are the first generation to see those limits, to recognize those limits, and ultimately to have to live by those limits. Crisis is an interesting word because it implies that, I don't know, but it just sounds a little too, nasty. I think it is a moment of reckoning. I think it's one of those watershed moments where in human history, how are we going to deal with this? Are we going to deal with it in what I call an elegant fashion, where we don't have large-scale food shortages and starvation and water shortages and resource shortages, and we don't have a real open and bloody conflict between the haves and have-nots on the planet? Or are we going to get to this point in a way that where you see huge amounts of social unrest, where you see real problems to the economic system, where you see widespread starvation at scales that we've never seen before, widespread lack of water on scales that we've never seen before. Water, it's an interesting point that we see water shortages in areas that typically never saw water shortages, like southeastern U.S. And, I come from there. It rains a lot. It still rains a lot. But drought now is defined not only in terms of how much water, but how much water do we get relative to our use. And if we're using lots of water, then a small drop in the rainfall produces a drought, where that was not a drought 20, 30 years ago when we were only using maybe 50% of the available water. Today we use something like 70% of all the available surface water. So you imagine as population grows, as wealth grows, we're very quickly reach a point where water is going to become the same kind of issue that we see oil and natural gas and coal being today. This is an important point, as water gets recycled and reused. And if we didn't do that, we would not have enough water, particularly here in the West, but also in the eastern part of the United States. There wouldn't be enough water. For industry, which uses a lot of water, for agriculture, which uses most of the water, but also for municipal supplies, you know, the stuff that comes out of your pipes for drinking water, for flushing toilets, etc. You know, we're on the edge. We can't afford to use that stuff once and then assume that we can cycle it back in the system and not use it again. Water's used repeatedly from the west to the east, basically, because that's the way the weather patterns go. But water will be used here in the west. It may go into a river, may get transpired by crops, put back in the atmosphere, falls as rain again, gets reused, or flows in a river, even more directly. Comes out of a sewer system here in Colorado, goes up the Platte River, gets used in Nebraska, gets used in St. Louis, you know, gets used in Memphis, gets used in New Orleans, and then finally makes it out into the Gulf of Mexico. This is an important issue. Everything on the planet recycles. It's a finite planet, and we need to recognize. I think a lot of people don't frankly understand where their water comes from, or where their electricity comes from, or where their food comes from, for that matter. But if we don't recycle, we don't survive. So we're in a situation where, just from the raw number of people and the amount of resources we use, that we need more and more resources. We need more food, we need more water, we need more everything. What climate change is doing is compounding that problem. It's changing the baseline, if you will. If we need a certain amount of water in Africa or in Asia, and climate change reduces the total amount of water that's available, then that creates an additional problem on top of just the fact the population is increasing, and that resources are increasing in terms of the amount we use per person. A good example of that is hurricanes. It's been pointed out, and I think very correctly so, that we put ourselves in harm's way. We build vacation homes at the beach, and more people do that. 50 years ago, you could drive along the Atlantic and on the Gulf and for miles and not see people. Today, it's almost completely populated. If you look at a picture of the Earth at night from outer space, there's lights all along the coast. All right, so if we have a situation in which hurricanes naturally occur and they naturally plow into land, we are naturally putting ourselves in harm's way, and we're increasing the amount of people we put in harm's way. Now imagine if, by climate change, the amount of hurricanes increases and the intensity of those hurricanes increases. Now these are really important questions. We don't really know in detail the answer to these questions, but imagine if climate change then changes the baseline of hurricanes that come into land. Then you've got this double whammy, I call it, where you've got more people, and then you've got a climate change which changes the risk level that we all see. That goes on all over the globe, in industrialized countries, in non-industrialized countries. This double whammy is occurring. There are very few places where population is stable. Population is still increasing almost everywhere, and resource use is increasing almost everywhere. And yet climate change is, in many places, lowering the amount of water that's available, which means you can't grow as much food. Climate change is making it hotter, so that you have more hot spells, which puts people at risk health-wise, which makes us buy more air conditioners, which makes us use more fossil fuels. There's a lot of little nasty feedbacks that are in there. Looking at these big problems that we face, in general, the problem of sustainability. How do we achieve sustainability? And all the subset underneath that of climate and water and food and all the resources, all the other issues. In looking at those big pictures, there are three actors that need to join together if we're really going to have solutions, effective solutions, and solutions that occur on a time scale that's useful. I mean, if solutions take hundreds of years, okay, that ain't going to work. And those three actors are the public, because they need to be educated and they need to put pressure on. They need to know it's their planet, after all. I mean, it's our common backyard. The second actor is the information gatherers, the scientists, the policymakers, the people who gather the information that the politicians, the policymakers and the politicians and the governments use to act on. So I think if you don't have those three actors agreeing and working together, then things aren't working very well. An example of a scientist speaking as a person is if someone asked me the question, do human beings cause climate change? I will say yes, and I won't say anything more, because I don't need to say anything more. All right, I've answered your question, and I've not equivocated. I've not, given all the arm waving that I'm doing now. I'm just saying yes. All right. Now, as if you asked me that question as a scientist, are human beings causing climate change? I would go into all of the details, and how do we know that, and what are the uncertainties, and where are the areas? What's the soft underbelly of those uncertainties? Because that's what we do as scientists. We're always looking for the soft underbelly of our decisions. Where's the weak parts in that? I think if you do that with people, with the average person on the street, if you ask me, are human beings causing climate change? And I say, yes, but, as soon as I say but, I've lost the message that I want to convey. And the message I want to convey is that, yes, human beings are causing climate change. I think the key is we have to come to a consensus on what it is we know. What's the basics here? Can we agree that human beings are causing climate change? And if you talk to climate scientists, those who look at the system, they say yes. There's it's now the evidence, our understanding of the physics of climate and everything is sound enough that we can say that yes, if you add as much greenhouse gas as we've added to this planet, you will change climate. Now, and I think that's important because every Coloradan ought to know that we are doing that there's enough of us, we have the capability technologically, and there's enough of us that we can change the climate system. And I think here in Colorado, I think we know that because we live in a resource-limited world in terms of water. We all know that human beings play a huge role in the water system because we run out of it every now and then. We go through droughts where we can't water our lawns, or we don't have enough water for the farmers on the eastern plains to grow the crops they want to grow, or to grow any crops in some years for that matter. So we understand that human beings are a big part of our environment. I think many people have struggled to really accept the fact that human beings could cause climate change. And this goes back to this fundamental point that I think everybody has to learn, has to digest, and that is that yes, there's enough of us, and yes, we use enough raw materials, and we use enough of everything that we can change this planet, and we are changing this planet. Now, and that's one of those baseline pieces of information. If we all agree on that, then we can start getting into some interesting arguments about how do we deal with that. What do we do with fossil fuels? How are we going to deal with resources in the future? Do we want to build more coal-fired power plants? Do we want to invest in wind? There's a lot of pros and cons that have really, I think, very interesting economic twists to them, sociological twists to them. Do we want to proceed down pathways, for example, that would eventually eliminate the ability of farmers on the Eastern Plain to farm? In other words, do we want to do as we're doing right now? We're taking a lot of water away from the farming community and putting it into municipalities. They're buying their water rights. And so we're seeing a cultural shift. These are the big questions that I think Coloradans really ought to be thinking about and ought to be pressing our government to think about. What are we doing with our world? What are we leaving to our children? Those are the big questions. Honestly, I think that most of what's behind the denial game these days is money in politics. There's a lot of money tied up in natural resources, including fossil fuels. And that's just, whenever there's that amount of money, even if it's a small amount of the total economic pie, it may still be billions of dollars. So this is still very important to some group. And I think it's unfortunate, but we live in a world where people are really willing to push their own agenda at the expense of the state, at the expense of everybody else. And sometimes that's hard to see. I think probably the most interesting factoids or tidbits to me that convey just how big we've become is that if you look at all of the fossil fuels that have ever been burned, all the coal, all the oil, all the natural gas, all of it, half of it has been burned since roughly 1980. That shows you the power of that rising exponential. Of all the fertilizer ever produced by humans on the planet, something like 80% of it has been produced in the last 30 years or so. Those numbers may be slightly off, but it shows you that the pace of change is increasing and increasing rapidly. And so when I run into people who say, is this climate change thing real? How can human beings possibly be doing this? You say, well, look, my generation burned most of the oil. I'm 55 years old, and my generation will burn almost all the oil that ever existed on the planet. We started back in the early 1900s really taking this stuff out, but we didn't get really serious about it until the 1950s. And that's when you look at all the oil burned, like 80% of it will be burned by my generation. And that's pretty remarkable to me, that you take something as fundamental as a resource like oil on the planet, and you realize that one generation can pretty much wipe it out. And you realize, either this is a very small resource, or human beings have a very big impact. And I can tell you, if you look at all the oil rigs in the world, it's not a small resource. So it is human beings having a very, very big impact. I have two sets of visions for Colorado 50 years from now. I have my pessimistic, well, if we keep on the path we're on kind of vision, which unfortunately I think is tinged with realism. And then I have a more idealistic, what if we really get our act together and start dealing with these problems vision. And I like to think positively. I teach, 350 bright shining faces out there, really smart minds, problem solvers. It's hard to be pessimistic when you teach, because the future's right out there in front of you. In my idealistic vision, I see a state that is heavily invested in alternative energy, that is a world leader in wind, a world leader in solar, and has a thriving economy that is making gobs of money based on those kinds of alternative energies. I see us struggling with water. The predictions for the future are a hotter Colorado, and a hotter Colorado is going to be a drier Colorado just because of evaporation. And I see us struggling with water. I see, unfortunately, a lot of the traditional parts of Colorado, agriculture, mining, etc., becoming less important because of the large needs for water in those areas. But I don't think that's, I think that's an evolution of Colorado. I'm not sure I really enjoy that evolution part, because I think that's really important. Our state's history is valuable to us, and we're very, very proud of that. Pessimistically, one can imagine a Colorado in which water is reached a point of crisis, where we simply don't have enough of this to supply even some of the most basic needs for industry, for agriculture, and for municipal supplies here in Colorado. Unfortunately, this is not something that we can control in Colorado alone. We've got to push the system. It is in our best interests to be a leader in dealing with climate change, because we are one of the canaries in the coal mine. Here in the West, we are on the edge already, and it's definitely in our best interest to convince the rest of the world to do something about greenhouse gases, to do something about climate change, because that's going to benefit us. And I think the way that we do that is to be a leader in alternative energies, to be a leader in education, to be a leader in producing problem solvers for the rest of the world. And I think we can do that. It's a moral obligation. It is our obligation. It's our generation's obligation to do that. I think every generation faces fantastic challenges. This is ours. Sustainability is our challenge. And I would love to, reach a ripe old age and look back and you go, you know what? My generation did itself proud. A couple more factoids and little tidbits I think everybody in Colorado ought to know. One is the impact of human increase on carbon dioxide and greenhouse gases in the atmosphere. I do ice core work, so we use ice cores to look roughly 800,000 million years into the past to look at levels of greenhouse gases in the atmosphere. We are at a level today that is well above any level that we see in the last million years. Changes that we have produced in carbon dioxide are also huge. The carbon dioxide changes in the atmosphere every time we go through what we call a glacial interglacial cycle, where today we're in an interglacial period. At times the Earth has cooled off enough that huge glaciers have formed, covering all of Canada, covering all of Scandinavia, lowering sea level by over 300 feet, for example. That's how much ice is loaded up on land surfaces. The amount of carbon dioxide change between an interglacial period and a glacial period is 100 parts per million of CO2. It goes from 180 to 280 parts per million. This year, actually 2007 I should say, we hit 380 parts per million. Human beings have changed in a short period of time, in 150 years. We've increased carbon dioxide in the atmosphere by the same amount that was accompanying a huge climate shift between glacial periods and interglacial periods. So our increase of CO2 is by no means trivial in a climate sense. It is huge in a climate sense. And I think that's a piece of information that we all need to comprehend and to digest. That we're not pushing at the margins here. We're not, causing a little bit of change here, a little bit of change there, and then scientists argue about whether these little changes are fundamental and important. These are big changes, and these are big changes that are going to have profound impact. These are big changes that are going to have profound impacts in the future if we don't deal with it. Climate system, fortunately, has some inertia. It takes a while for it to catch up. As a climate scientist and as a paleoclimate scientist, I can look into the past and say, okay, when was the last time we had 380 parts per million in the atmosphere? What was the climate like at that time? The climate at that time, about 3 million years ago, is when we had 380 parts per million, was a completely ice-free Arctic, a little bit of probably an ice sheet in Greenland, but there were trees growing up to the edge of the Arctic Circle, pine trees, some deciduous trees. Very different world. The Arctic was in the neighborhood of 20 degrees Celsius. That's 40-something degrees Fahrenheit warmer than it is today. Very different world. Now it takes a while. I mean, if we'd have to sit at 380 for some period of time, and we don't know what that is. It's centuries, maybe longer. I don't know. We don't know. We'd have to sit there for a while to reach that point. But we're at that point today. And that leads me to if I was to predict what we're going to do from a climate, from a greenhouse gas point of view, I think that geoengineering is going to be a huge topic in the next 20, 30, 40 years. We've already put so much greenhouse gas in the atmosphere that we're acidifying oceans, we're changing ecosystems, we've got a climate system that's way out of balance. We're not stopping our burning of fossil fuels anytime soon. So we'll reach 400 parts per million. We'll probably reach 400 and something parts per million. I hope we don't reach 500, but this is entirely possible. So one of the key industries is going to be how do we take these greenhouse gases purposefully out of the atmosphere and sequester them into some form that's not going to go back to the atmosphere on any time scale that we care about. And this is a huge challenge, and it's going to be expensive. But if we really are serious about stopping climate change, and by the way, that 3 million year ago period, not only was Arctic warmer, sea level was 75 feet higher. 75 feet is bye-bye to Florida for the most part. I mean, if you want to gauge that, there's an island out there where Disney World sits in Orlando, and that's about it. And maybe Disney World likes that. I don't know, but this is profound change we're talking about here in terms of the planet. And I think we need to, like I said, we need to recognize that, but we also, if we're serious about stopping it, we're going to be doing some things that today's generation never even heard of these terms. By the way, what is greenhouse gas geoengineering? Well, we're all going to know that in 10 or 15 years. This will be on the cover of Time. Easy prediction. As a citizen of Colorado, and as a scientist, I'm very happy with what I hear out of Governor Ritter's office. I think he's saying the right things and doing the right things in terms of carbon sequestration, in terms of alternative energy, fostering that, getting research centers. ConocoPhillips building a huge research center here in the Front Range. That's an oil company, but oil companies can't be oil companies in 40 years. They've got to be energy companies, or else they're going to be out of business, because oil isn't going to last for forever. So I think we're doing the right things. We're taking we're making this, I think, the hotbed for alternative energies, for solutions. And this to me is as a climate scientist, one of the big frustrations that I have is the lack of solutions. We talk a lot about what's going on, but we don't solve things as often as we should. And one of the real, I think, failures of my generation over the last 20 or 30 years is the failure of our ability to deal with the climate change problem. We knew back in the 70s, Jim Hansen got up in front of Congress and said, we're changing greenhouse gases, we're changing climate. He was right. We had 30 years to figure out, all right, how are we going to deal with this? How are we going to ramp away from greenhouse gases and into alternative energy? We shouldn't have gotten to this point where we're 380 parts per million in the atmosphere before we start affecting solutions. I think that's one of these failures that we need to deal with, and we shouldn't repeat. We're smart. We're thinking beasts. We're smart enough to not continually do the same stupid thing all over and over again. I giggle about it because maybe we're not, but we're certainly smart enough not to do that. But let's demonstrate that intelligence. Let's reach that point of accepting responsibility for the true position we have, not only in Colorado but on the planet, and then act responsibly. And acting responsibly means solving some of these problems. So I like what I hear out of the governor's office. Individual citizens, the people of Colorado, I think, can do two things that are very important. Number one is educate yourself. Read the Intergovernmental Panel on Climate Change's report. There's a summary for policymakers. And believe me, if they wrote it for policymakers, then anybody can get out there and digest this thing. So educate yourself. Know what the facts are. Don't be fooled when we hear ads on the radio or on TV about, we don't want to do this, or we should be drilling for more oil or something like that. Don't be fooled by what's being said. Educate yourself, because I think that's absolutely critical. And I mean everybody here in Colorado needs to do that. The second thing you can do is then, once you've got some of that education in your head, and you for yourself decide, what level do I want to contribute? Do I see this as an enormous problem, so I want to enormously work for a solution? Do I see this as less of a problem, but big enough that I want to take some action? I think it's, I'm not a dictatorial type of person. I wouldn't recommend that we all have to do something. I would recommend that, however, once we understand the scope of the problem, I would expect almost everybody to take some action. So find your level of comfort in dealing with this problem. If it's buying a hybrid, fine. Your gas is $4 a gallon. You're helping yourself out. If it's recycling, fine. If it's educating your neighbors who may be still kind of stuck in the mud about whether or not climate change is real, do that. But take some action. We all live together. It's a society. We all love this state. It's a beautiful place. Without the natural resources, without the natural beauty, we don't have Colorado. And we as Coloradans have been given a wonderful gift. Let's protect it, let's use it responsibly, and let's leave it to our children in the same way that we found it, if not better, hopefully better. As a climate scientist, I do my work in Greenland and Antarctica because that's where the big ice sheets are. And we're seeing profound changes there. We're seeing melting of these large glaciers. I can tell you that big field work in Greenland, oddly enough, requires it to be very cold, because our ice is our archive, and so if it's not very cold, we lose our archive. And we've had to adjust over the last 20 years to the fact that it gets warmer and warmer in the summertime. We have trouble flying planes in and out because the snow gets too warm and melty and sticky. We have trouble doing our ice core processing. We have to dig down into the snow to do all that stuff. So oddly enough, we need to keep it cold in order to keep that archive working for us. So we've seen in Greenland and in the Arctic profound changes. The sea ice retreat of last year was just huge and an enormous wake-up call to all of us. Interestingly, we here in Colorado are sharing some of those profound changes. Our Alpine is one of these cold regions that is very sensitive to climate change. And I'm sure that many Coloradans who get up in the high country frequently during the winter and during the summer have seen those changes. If you're a big skier, you know that snow is coming later, it's melting out earlier, nighttime cold temperatures, which are needed to make snow, are occurring later, and so ski resorts are opening later. It may be only a few days or a week or two, but eventually that's, we don't ski all year round, so we need all that time. You'll also see changes in ecosystems, changes in the kind of vegetation you see up there. These days, one of the most profound changes we see is the pine bark beetle. If you've driven up in the high country of Colorado, it's just shocking. It's brown when it ought to be green. And scientists tell us that that bug has been enabled, if you will, by the fact that it's gotten warmer and warmer, and its ability to thrive in this area when it didn't before, they think is tied to the fact that it's gotten warmer. So we live in, as I said before, we're one of those canaries in the coal mine, and we need to recognize that and recognize that we have some fragile ecosystems up there, systems that are vulnerable to change and are being changed. We used to have a lot of little glaciers in Colorado. Go up and take a look at them these days. They're retreating rapidly. Oddly enough, we have colleagues here at INSTAAR who are making lemonade out of these lemons. As these glaciers retreat, thousands of year-old artifacts from Native American populations are beginning to emerge. Thousands of years old. We can date these things. We know how old these things are. So we know that these are glaciers that have been here for long before Europeans showed up here in Colorado. And we're watching these glaciers disappear. And so we're losing part of our heritage. We're losing part of what makes Colorado unique and Colorado. That's sad. And I think we need to put the brakes on that and deal with it. A fundamental problem that we have as climate scientists is getting people to recognize the huge changes that have occurred in gases like carbon dioxide and methane in the atmosphere. I wish carbon dioxide was red so that people could watch over the years the sky getting pinker and pinker and pinker as more CO2 is added to the atmosphere. It's not. It's transparent. You can't see it. So we have to make measurements and then write down numbers and try to get people to digest those numbers. Or we make graphs and try to get people to digest those graphs. Visuals really work. I've sort of pondered in whimsical moments, what if we could add something to fossil fuels the way that they add a smell to natural gas? That smell of natural gas is not natural gas. It's something we put in there so that we know that there's a natural gas leak in our house, because our nose works a lot better than, say, if we had a little graph on the wall of this is how much carbon monoxide you have in your home or something, or natural gas leakage you have in your home. I wish we could put something in fossil fuels that would change the color of the atmosphere. That'd be cool, because then you could say, this guy's getting really pink today. We must be burning a lot of carbon dioxide, or it's gotten a lot pinker over the last 10, 15 years. If Colorado was alone in dealing with climate change in the world, it would still be very much worth doing for two levels, for two reasons, I should say. Reason number one is it's the right thing to do, all right? Because, and as I said many times here, we stand to lose with climate change. And if anything else, we can't just look to the rest of the world and say, well, they're not doing it, so we're not going to do it. That's about two-year-old behavior, and we need to get out of that mode. The other important part of doing it anyway is that we will be leaders in the technology. We will be economically benefiting from that technology when it's ripe and ready to feed in. We're not going to have fossil fuels forever. We've already seen the limits of oil. U.S. domestic production of oil peaked in the 1970s. It's been going down ever since then. Global production is peaking as we speak. It's going to start going down, so the prices are going to start going up. If we think that coal right now has a lifetime of hundreds of years, 400 or 500 years. If we switch from oil and natural gas to coal, and if coal becomes our only source of energy, and you let the economy grow the way it has been growing, coal won't last till the end of the century. So fossil fuels are finite. We need to understand that and recognize that. Moving into alternative forms of energy is something we got to do anyway. It may cost us a little today to invest in those technologies, but if we're the world leader in pushing those technologies and selling those technologies and using those technologies, then the economic benefit in 10, 20, 30 years is going to be enormous. Look at what our parents and grandparents did to set us up for success. They invested in the interstate highway system. Right? Ask yourself, would we do that today? I don't know that we would. But without that, do we have the kind of commerce that we see today? The kind of goods that can move freely around the United States, oddly enough by cars. But, that was an investment that our parents made in our country that paid off, not so much for them, but hugely for us. Putting in sewer systems, putting in roads, these are the kind of investments that we make for the future. We don't expect that to pay off in 6 months or the next quarter. Right? I think this is what Colorado needs to be doing. We need to be investing not only for ourselves now, but also for the next 10, 20, 30, 40, 100 years. And that's a smart thing to do no matter what, because Colorado will be then well situated to have a vibrant economy and to be a world leader in these technologies when the time comes. The question I get asked every now and then is what keeps me up at night? And one of the things that causes me to have 3 a.m. conversations with myself is Arctic carbon. It's the amount of carbon that's currently locked up in frozen soils, in permafrost, in Canada and Alaska and Russia, the colder regions of the world. These are regions that have accumulated carbon because there's a little bit of plant growth in the summertime, but it's not too much. But this carbon doesn't decay away very rapidly, so it accumulates in these frozen soils. There's enough Arctic carbon to cause us some real trouble. The amount of Arctic carbon is roughly equal to all coal, oil, and natural gas that ever existed. This is stuff that, as the Arctic warms up, percolates out to the atmosphere by bugs eating it, basically, the way the natural system works, what we call respiration. It'll come out as carbon dioxide. It can come out as methane. Methane is 20 times more powerful greenhouse gas than carbon dioxide. We could be, and I think we are, heading for a situation in which our warming of the Arctic by our greenhouse gases will trigger a natural release of what we call a positive feedback of carbon coming out of these frozen soils and going up in the atmosphere that will dwarf our fossil fuel burning eventually. This is the kind of scientific problem that creates real big policy problems. I mean, if you're a policymaker and you say, all right, I'm going to cut back on oil and natural gas and we're not going to use coal as much, we're going to sequester, or if we use coal, we'll sequester the CO2 in the smokestack and remove that. If we do everything we're supposed to do, yet the natural system, because we prodded it, starts to produce this extra amount of greenhouse gas and still raises greenhouse gas levels in the atmosphere, then it makes it very difficult for policymakers to sell to the public, you're doing something good. You're not seeing any result, by the way, but you're still doing something good. This is a big, big problem. It could end up raising greenhouse gas levels to much higher than we see today, much higher than we would have seen, even with responsible human action. So we need to recognize that in having this dominant position on the planet, that there's also, the planet is still out there, and it's reacting to our actions. And that if you have trouble digesting the fact that human beings can cause climate change, try digesting the fact that our actions can then trigger the natural system to do something. And that's what we're doing. We're warming up the Arctic. We're starting to see these permafrost melting. If you got friends in Alaska, talk to them about it, because they see structures tumbling into the ground because of permafrost melt. When that permafrost melts, That's carbon dioxide, that's methane going into the atmosphere and adding to what we do. And if the amount was small, no problem. But the amount is huge, and it could end up being a huge problem for us. If our actions cause one of these positive feedbacks, I wouldn't call it a runaway system, but certainly a system that is getting out of our control, then we are screwed. I mean, what are we going to do? Then we'll have to invest enormous sums of money into trying to find ways to take that carbon dioxide and that methane out of the atmosphere and put it someplace else. And if you look at the globe, there's a lot of area up there, a lot of land area up there, and if all that stuff is producing carbon, think about the engineering, the scope and the scale of the engineering problem you're going to need to try to remove that CO2 from the atmosphere and put it away somewhere. My guess is if this starts to get out of control, that we simply are going to have to deal and adapt rather than mitigate. We're just going to have to adapt to rising sea level. We're going to have to adapt to a hotter climate, and that's the pessimistic side of our future. And that is kind of, in a nutshell, what, as a private citizen, drives me nuts about, what we're doing. We're creating problems for ourselves. We're creating economic challenges for ourselves at a time when I think we ought to be investing in other areas, when we have other problems to solve. The roads are not in superior shape. The bridges are not in great shape. Higher education, University of Colorado at Boulder gets less than 9% of its total budget from the state. We're not supporting education in the way we should. And the folks down there in Denver, they recognize this, and they're frustrated by it as well. And to add an additional frustration that our actions would then cause problems that are going to cost us lots of money in the future, this just seems dumb to me. I'm not an economist. I'm just saying this as a citizen of Colorado. It just seems dumb to me that we would continue down this road when we know that this is going to cost us money in the future. Sea level is one of those issues that we're still in our infancy from a scientific point of view in terms of understanding how rapidly sea level is going to rise and what are sort of the ultimate levels of sea level. But the speed is really important. If sea level rises at a very low rate, then we as industrialized societies and even the poorer societies can adapt to some extent. We can move away. In some cases, you can't move away. The Bangladeshis are not going to move elegantly into India without some real problems there. But if things happen slowly enough, we can kind of deal with what goes on. We may have to give up Florida eventually, but we can deal with it. If sea level is rising faster, then this creates a bigger problem, because we got to start relocating. We got to start spending lots of money, relocating. And it's not just people. I think we tend to think about, well, I'm just going to move from Miami. All right, that's there's a lot of infrastructure. There's water treatment plants. There's sewage treatment plants. There's electrical lines. There's roads. A lot of infrastructure is down near the coast, and we have to deal with that. We have to move that. EPA has a very good website on the challenges that we face from sea level rise. So how fast sea level rise and how what it gets to pick here 2100, that's an important question, and I wish we could give you a really solid answer. But what we can tell you is that all the answers we've given thus far are conservative. This is another kind of interesting issue between science and science policy. Should scientists be conservative, or should they, push the envelope? If you're conservative, I think you give sort of a false sense of security. And I think it's, in a sense, what we've done as scientists, as those of us who look at sea level, look at ice. The projections for 2100 are, somewhere in the neighborhood of a quarter meter to a half meter, something like that. I think we all recognize now that we did not include, many of what we call fast feedback processes. Ice just doesn't melt. Ice can flow into the ocean as well. And by flowing into the ocean, we can raise sea level much faster. The people that I talk to tell me roughly a meter of sea level rise by 2100. And you can go online and find out what a meter means, but it's non-trivial. New Orleans doesn't have much of a future with a meter higher sea level rise, or a meter higher sea level. Many big cities along the coastal U.S., Houston, Miami, Norfolk, you name it, 3 feet is a serious problem. And a lot of it has to do with that infrastructure issue and not so much, well, my home's 3 feet above sea level. Yeah, well, maybe your pipes aren't, That can be a problem. Whether it be more than a meter, this is a big question. And this is a question we ought to be pouring a lot more of our resources into solving than we are today. Sadly, we're at a time when we're struggling for dollars for science, when we ought to be, saying, what, you scientists, you've got a job to do. You got to figure out how high sea level is going to be, in 2100 and in 2200 and 2300, and we're going to task you with dealing with that. We're going to give you a Manhattan Project kind of, you go figure that out. We're not doing that these days. We're sort of still got our heads buried in the sand. And unfortunately, when your head's buried in the sand, there's other parts of your anatomy that are exposed, and we're exposing it right now. It's moving power stations, it's moving industry. And these are, if it was, like I said, if it was a small amount of money, then okay, but this is a fairly large whack to the system, and it's something that our children are going to have to pay for. I can't see any way around it right now. We've already got so much greenhouse gas in the atmosphere, and we're warming up, and as I said before, there's inertia in the system, and it's just going to keep going. All right, even if we stopped burning all fossil fuels today, the climate will warm up for another 50 to 100 years, and sea level will rise for another 100, 200, 300 years, because the ice systems have a slower reaction time. So, they're going to be paying for it, and they're going to be adapting to it. And the kind of problems that we saw during our generation, they're going to see a different set, but it's the same kind of thing. You're just going to have to learn to adapt to it. I think it's important to avoid being pessimistic. And I'll give you an example. In the 1960s and 1970s, the air in our cities was much worse than it is today. And water pollution was much worse than it is today. I remember, articles about Lake Erie being dead. Lake Erie's not a small chunk of water. These are problems that we faced as a country and dealt with, I think, pretty darn well. The Clean Water Act, Clean Air Act, these are things that had profound impact. We don't have that kind of pollution going into the system anymore, or at least not in the volumes that it was at that time. So we saw a problem, we dealt with a problem, and we are now much better for it. I think one of the challenge to our children and our children's children, I think everybody from beyond or on out in terms of generations, is that the problems that we see coming are global problems in part. Certainly there's still going to be the local problems, it's still going to be there. But the global problems, we don't have a good global solutions. We don't have a good strategy for global solutions. Kyoto was a wonderful first step, but everyone, I think, recognizes it was a baby step. And you got to take the next step. And the mechanisms by which we get, the richer countries to agree with the poorer countries, to agree with those in the developing countries, to everybody to come some common goal and some common strategy for action. We don't have those mechanisms, and we got to get them. This is an enormous challenge.